All right. So let's start with the syllabus today. All the logistical stuff, let's get that out of the way. So this is ECE 4570. This is fall 2015. You can see I still have the 2014 up there. Okay. So the credits, number of credits for this class is going to be 4. You can see the meeting times. My office hours are going to be an hour before class, 2:30 to 3:30 Tuesdays and Thursdays. I realize that may not work for some of you. I know many of you work, so if you do need to meet outside those times, feel free to let me know and set up specific appointments either earlier or later in the day. Mondays and Wednesdays, I have class from 5:30 to 7:30, so I could potentially meet with students between 4:30 and 5:30 if you need to come later in the day. The final exam time will be on Thursday, April 30th. I'll go over the course calendar in just a second. So what is this class about? Electronics 2 is about the electrical properties of semiconductors, physical electronics of PN junctions, bipolar field effect transistors, device fabrication technology, essential to understanding semiconductor active devices and integrated circuits. Okay, so that's a mouthful. This class is about semiconductors. Okay. Does anyone know what a semiconductor is? Has anyone heard the term before? Yeah, that's one of the properties of semiconductors. So the resistance of the material changes with temperature. Yes, that's one of the properties of semiconductors. And the general definition of a semiconductor is a material that's sometimes conductive and it's sometimes not. Okay, we've learned about, in physics, you've learned about insulators and conductors, right? Insulators do not conduct electricity. Conductors always conduct electricity. Semiconductors are somewhere in the middle. Okay, that they can sometimes conduct and sometimes not conduct. And we're going to be talking about how, what causes them to conduct sometimes and what causes them to conduct some other times, or what causes them to conduct and not conduct. And it turns out that ability is very, very important. It turns out that if you have a material that can be conductive sometimes and not conductive other times, and you can control that, then you can make things like switches. And from switches, you can make logic gates. From logic gates, you can make computers. So the fact that we have semiconductors is ultimately what has led to computers that we have today, and also the wireless communications that we have today. Your laptops, your cell phones, Google Glass, Fitbits, everything, like all of those devices are based on semiconductors. We wouldn't have any of this stuff if it weren't for semiconductor technology. So we'll be talking about 3 different types of devices. Actually, mostly 2. In the past, we've done 3, but I've shortened the class a little bit so that we can go more in depth into fabrication technology. The 2 types of devices that we're going to be focusing on in this class are PN junctions. PN junctions, what's another word for PN junctions? Diode. And we'll be talking about semiconductor diodes, and we'll be talking about field effect transistors. They're also called MOSFETs. Have you heard the term MOSFET before? Okay. What are MOSFETs used in? I'm sorry? Amplifiers, right? That's one of the things. How about, what's the other thing? Logic gates, right? 2 biggest uses of MOSFETs. For amplifiers, when you use MOSFETs and amplifiers, you can make things like transistor radios. You can also make wireless communication devices. So that's the basis of the communication part of your cell phone. Logic gates, the second thing that was mentioned, logic gates are the basis of microcontrollers and microcomputers, microprocessors. So that's for the computational parts of your cell phones. Okay. So the reason why we're focusing on diodes and field effect transistors is because those are the 2 devices that are used, by far, they're used the most in today's electronic integrated circuits. It's true that bipolar devices are also used. They're used a little bit less than the other devices. And so I've decided to spend a little bit less time working on that, and instead introducing the class to a little bit of device fabrication technology. So one of the things we'll be doing in this class is having 2 or 3 class sessions in the clean room. Okay, we have a microfabrication facility here on campus. We're very fortunate to have that. When you come up on the 3rd floor in the elevators, it's that room right next to the bathrooms with the windows and the yellow-colored lights. So that is our microfabrication facility. We can actually do some of the semiconductor fabrication processes that are used in industry. We don't do the whole thing. In fact, no universities really do that. All of that semiconductors are fabricated in these foundries, as you well know. And foundries like Freescale, Intel, and a lot of foundries over in Asia. Actually, when I was over in Singapore, I saw a bunch of those foundries this time around. And they're multi-billion-dollar facilities. So those foundries can actually do all the steps required to make a semiconductor device. We can do some of those steps here on campus, and you'll see how to do that. So we can make devices like diodes. And so you'll see a little bit on how diodes are made, different tools that are there, what they look like, and you'll be doing a little bit of testing. It's not as much as you'd get if you took a full class on microfabrication. You could spend an entire year learning about that, but we're going to have just a couple of classes on that just so you can get your feet wet and appreciate how semiconductor devices are made. There's a reason for that. When you guys sit and make your breadboards in your Circuits 1 class, right? You know that making anything more than a 2-stage amplifier is a pain in the butt, right? Because there's so many components that you have to put on there, and sometimes a component won't work, so you have to replace it. And then you get all these parasitic capacitances, parasitic things. If there's wireless signals in the room, all those little wires, they end up picking up the radio signals and so on. It's difficult to make very complex circuits. More than 20 or 30 circuit elements is very difficult to lay that on a breadboard. Semiconductor chips, you have literally billions of elements, billions of transistors that are made into this really, really tiny chip that might be just half a centimeter by half a centimeter in dimension. The fabrication technology, how we can actually manufacture transistors and diodes that small so that you can fit that many devices on a small chip, that is an essential part of semiconductors and why they've become so pervasive in our daily life, things like laptops, cell phones, and what have you. Okay, fabrication technology is almost as important as the semiconductor technology itself. So I was joking a little bit earlier in the day saying that this class is going to be all theoretical. We will cover some practical aspects of how semiconductors are made. And we'll also try to keep a bit of a practical focus on this class, so it's not all theory. Okay, backing up a little bit to prerequisites. So we have the prerequisites for this class would be Circuits 1. The physics and material science courses you don't necessarily need to have. In terms of what you should have to do well in this course, if you can analyze electric circuits, that will make your life much easier. If you have an understanding of Newton's laws and differential equations, that will make your life easier. If you don't understand those things, it doesn't mean that you're going to completely fail in this course. It's just it just makes things a little bit easier if you understand those. The concepts that I'm going to describe, I'm going to be describing them at a very conceptual level. I would think that even if you don't have background in some of these things, that you'll still be able to understand them. But the first one, the analysis of electrical circuits, I really believe that you should have that. So if there's anyone who has not taken Circuits 1 or has no background in circuit analysis, then please do talk to me after class. Okay, so moving on here. Learning objectives. So I want you to be able to understand the physical concepts underlying the operation of semiconductor devices. That's the first one. The second and third learning objectives are, second one is learning about diodes. The third one is learning about field effect transistors. So that's going to be the second half of the class, the two types of devices that we're going to drill down on and understand, diodes and field effect transistors. The first half of the class is these physical concepts, the physics of semiconductor devices. So it's basically learning the ABCs of semiconductors. And then in the second half of the class, we'll apply that knowledge to the two types of devices that we're going to be focusing on. So when I'm talking about the ABCs of semiconductors, what I mean is things like what are carriers? Okay, there's two types of charge carriers in a semiconductor. There's electrons and holes. You've learned in your physics class, you may have learned that electricity is the flow of electrons. In semiconductor devices, there are electrons, but there are also these things called holes. Holes are positive charge carriers. So we're going to be talking about those two types of carriers, and we'll talk about the four different processes that those carriers can do. Drift, diffusion, generation, and recombination. So we'll basically be learning the physics of those things. We're going to be learning something called energy band diagrams. Energy band diagrams are these things that semiconductor device engineers use to describe the behavior of a semiconductor device, the behavior of these carriers, what the carriers are doing. They're sort of these like line diagrams which don't make any sense at the beginning, but once you start using them regularly, you start to see why these types of diagrams are useful. So just a fair warning, at the beginning of the semester, when we start talking about energy band diagrams, you're going to wonder why we're doing these, why we're just drawing these circles and lines and these band gaps and such. But you'll see by the end of the semester why those energy band diagrams are useful. With regards to learning objectives 2 and 3, for each of the two devices that we're going to learn, we're going to focus on the physics of the device. We'll focus on the operation of the device and the characteristics and how the design of the device affects performance. For example, if you are designing a diode, how does the area of the diode affect the ability to conduct current? How does the doping affect its breakdown voltage? Just like if you were designing an automobile, like, how does the size of the car affect gas mileage and things like that? The same thing is done with semiconductor devices as well. There are certain performance parameters that you want to get, and there's certain design parameters that you can design to get those performance parameters. So we'll be talking about that. Some more general stuff. I don't want to spend too much time on this, but as an engineering program has to, in addition to teaching you the specific technical things, there's also this idea that we have to educate the next generation of engineers with just like some very general like life skills or soft skills that you should have as a graduating engineer. So each one of our classes in the Wayne State's curriculum addresses some of those things. And so I've listed some of them here and sort of talking about what this class in particular does to address those things. So as an engineer, you want to be able to apply the knowledge of mathematics, science, and engineering and the tools, the techniques necessary for engineering practice. So in this particular class, we're going to be talking about the physics of semiconductor devices. So that's more of like the foundational stuff, and we're going to apply that knowledge in the second half of the class to diodes and MOSFETs. And we're also going to be using the principles in mathematics to discuss the important relationships. The second thing is being able to design a component or device according to the needs of what your customer will require. So when we talk about diodes and MOSFETs in particular, we're going to talk about the design criteria versus performance criteria. And I always have tests in my exams about this. So if you want to design a diode to be used in a high voltage rectifier, what type of properties would you want that diode to have? Next is this now a few different items here. Being able to communicate effectively, having a knowledge of contemporary issues, and the need for an ability to engage in lifelong learning. So the way I see these things, okay, just to rephrase some of these things, is that we want you all to have an ability to learn and continue to learn as your career goes. So a lot of times what happens, you come in school because you want to learn about a certain topic, right? And then you go out in the work world and you apply some of those things that you learned. After you've been working for 10 or 15 years, you forget some of the things that you learned, and then that's that, right? One of the hallmarks of a good engineer is someone who's always up to date on technology. How many folks of you read blogs and things like that, like technology blogs? Okay, great. So it's a way to keep up to date on technology. What's new and great in the field of semiconductors, in the field of biomedicine, whatever field that you may be interested in. So one of the things that I like doing in this class to kind of teach that or give you some experience in that is that we do these class presentations. Okay, and these class presentations are very short. They're we limit them to about 6 minutes, 7 minutes, something like that. Basically, one student will come up to the front of the class and give a short presentation on a contemporary topic or a contemporary issue that relates to semiconductors. Okay, can't be on the politics of genetically modified organisms. Okay, it has to be related to semiconductors. And it turns out that this has been one of the funnest things about this class that I've really enjoyed since we started doing this about 3 years ago. It's true that some of this class material it's quite theoretical. It can be dry at times. And I think it's very important for you as students to see how this class material actually relates to the real world. Okay. So, and sometimes it's just fun to see what's happening in the world of semiconductors. What's new? What's the latest and greatest? What's the exciting things that are coming out at the Consumer Electronics Show? What is some interesting research that these people at a university is doing in the field of semiconductors? There's a lot of exciting and interesting things happening in this field. And I want you to come away from this class with an appreciation of that. So for that reason, we have these short presentations. I'll talk a little bit about it more as time goes on. But we will start those presentations not next class, but the one after that. And there will be 2 presenters per day. They will be no more than 7 minutes, and we'll have a couple minutes of questions, 1 or 2 questions from the class. So what you're going to do is that you will look up a topic related to semiconductors. It could be something like, it could be something industry related, it could be something research related. I've encouraged students in the past to do research related things, but industry things is also okay. So let me give you an example. You find, you do a search on Google Scholar and you find an article about how the semiconductor material graphene is being used for as biomedical sensors. Okay. The question you have to ask yourselves is, does the topic that I'm doing, does it involve semiconductors? Okay. Then you have to explain to the class how your topic is related to semiconductors, and you have to explain to the class why, why this thing is interesting, why is it new, okay, how it relates to previous work. So you could say, well, people have made other types of biomedical sensors before, but graphene is a semiconducting material that's also flexible. Flexible materials tend to do better in the body than non-flexible ones. Okay. Then you can talk about some of the specifics of the article, specifics of the results that you found, and then you can end with a list of references for further reading. Okay. This is not meant to be something that you have to spend weeks and weeks on. Typically 1 week should be fine. It's just a short presentation, and so the rest of the class can learn about what's on the cutting edge of the semiconductor field, and so that you can just get used to this thing about reading online to find out what's happening in the world of semiconductors. So it could be on electronics technology, modern research topics. So let me give an example of electronics technology. So let's say you didn't feel like doing a research article. Let's say Samsung recently released a new phone with a new type of Super AMOLED display. Okay, AMOLED is a type of organic LED, light emitting diode. It's a semiconductor device. So you could talk about this new phone that Samsung has released. You could talk about AMOLED technology. Why is AMOLED better than traditional LCD panels? Is there something specific about organic LEDs that are better than other types of LEDs, and things like that? And that's always fun because we're always interested in the latest gadgets, the latest electronic gadgets. And if you can relate it to what's some of the things that we're learning in this class, that just makes the class more interesting for everyone. Okay, so you could do that kind of thing as well. So yeah, this helps. This will help you in building your communication skills, sort of in an informal way. It'll help teach the rest of the class some of the contemporary issues and just appreciate the topic of electronics. We don't want electronics to become a dry and boring thing for you. We want it to be interesting. Okay, I'll talk a little bit more about that later. So textbook, there's a course textbook, the Streetman and Banerjee. It is available at the bookstore. It's also available online. If you can find a used version of the book, that's great. Some students in the past admit they have actually gotten by without the textbook because my homework assignments I actually just print out on paper, and I also post some of the solutions to those assignments. So students can get by without the textbook. However, I do recommend you have it because reading the textbook and reading up on a material that I lectured on is actually it's the best way to reinforce material. That being said, you'll be responsible for what I cover in the notes. Okay, I will post the notes. I will post lectures online, and those are the things that you're going to be responsible for. You won't be responsible for the stuff in the entire book. Besides the material in the class or in the book, some of these other textbooks in semiconductor physics you can also check out from the library if you're interested in. And the reason I mention these is not because I expect you to have like 4 different textbooks, but sometimes the way that I'm explaining it and the way that Puree explains a concept, it'll be different, right? And sometimes, in some cases, the way that I'm describing will be easier to understand. In some cases, the way that Puree is describing will be easier to understand. If you get accustomed to, reading up on a certain topic from multiple sources, you'll find that you can actually learn things a lot faster. I used to do this thing where if I didn't understand something in a textbook, I'd read that textbook over and over and over again. I'd spend hours and hours on it. And if I just spent like 5 minutes reading it on Wikipedia, it would be explained in a lot simpler way, or some places more easier to understand. So if you don't understand something, look at it from a different viewpoint. Read up it online. The stuff that we're learning in this class is an undergraduate level stuff. It's covered in so many textbooks, so many online sources, I couldn't even begin to describe it. And a lot of times, some of those sources may describe it better than I do. So I can help point you to some of those sources if when necessary. But here's a few of them. These popular semiconductor physics textbooks. There's online sources like Wikipedia, which I found that are very accurate, although there's no way for you to verify the accuracy of Wikipedia. However, it's been found that Wikipedia is actually more, on average, is more accurate than Encyclopedia Britannica, just because there's an army of people always editing it. Originally, when Wikipedia was started, they said that no, this is impossible. Like, you can't have an encyclopedia that anyone can edit. But somehow it just works. There's a book called I think is it Freakonomics or something? It might have been one of those other books that was talking about the concept behind Wikipedia and other crowdsourcing type things. Anyway. There's also a lot of online sources like MIT OpenCourseWare, there's Coursera, there's a lot of open university websites that have made their courses available for free online that I'm sure that you can find courses in semiconductors and so on. Has anyone heard of Khan Academy? Used that before? I found that website like amazing. There was one time I didn't understand a concept in statistics. This was just over the summer, right? So I watched several of his videos on covariance and some of these other things, and I was like, wow, this is really amazing. It's not just for elementary school students. There's actually a lot there for people of all levels. So things like those, actually, those are really good ways to quickly learn about a topic. And of course, last but not least, I have office hours. Feel free to come to office hours and let me know when you don't understand something. I want to make sure that everyone comes out of this class having learned a lot. Okay, it's 4:35 right now, so let's take a 5-minute break. When we come back, we'll do the rest of the course introductions, or introduce the rest of the folks, and we'll finish up with the rest of the syllabus and get into some of the material. Now, I'm going to pass around this sign-up sheet. You can either come up during break and sign up for your presentation slot during break, or after break, I'll just pass it around for those of you who haven't signed up yet. So what you'll notice is that this is the course calendar. Okay, on the left-hand side, you'll find the date and the course topics for that date. And on the right side, you'll have like a little blank where you can sign up for presentations. Some of the dates are blanked out because we have an exam that day, or you have spring break, or we're doing a lab that day. So please do sign up for one of the spots when you get this. 2 students may sign up for each day. Okay, and if all the spots are full, then we can go to 3 students on some of those days. Okay. And then we'll kind of go from there. I would like to have the presentation schedule sort of set up by today or by next class, because starting next week, Tuesday, we'll start doing the presentations, 2 per day. Okay, so I will leave this up here. We can take a 5-minute break. Okay. All right. So let's continue here. Let out then. Okay. So more about the syllabus here. Okay, we went over the course textbook. Let's go over the course modules now. And for this, let's actually let me bring up the course calendar here. Yes, I will do that. Yeah, what I'll do is I'll scan. I will scan that and post that on Blackboard as well, so you know. And yes, please do remember which date you have, because I often forget, and everyone needs to make sure that they do this by the end of the semester. Yeah, so in terms of course topics, rather than go into the details as we've done in the syllabus, you can read through the syllabus for the details. I found that it doesn't always make sense to everyone right at the beginning, so I'll just give you a brief overview of what we're going to talk about in this class. The different modules today and probably Thursday we'll go over sort of an introduction to the class. So besides the syllabus, that also means I'll talk a little bit about what semiconductors are, where they're used, why they're useful for our civilization, so that you have an idea of why you're taking this class, what this technology is useful for. Starting next week, we'll start talking about crystal structures and the electronic structure of atoms. So the first part of the class is we're going to take this approach where we say these are the atomic structures of a material, and then these are the electronic properties of the material. So if you remember when you take a course in material science, you say, well, this is the crystal structure of a ceramic. The ceramic is brittle. It has these types of mechanical properties. And then you have an amorphous material, like clay, and then you say that amorphous structures give, the mechanical properties of an amorphous structure is different than that of a crystalline one. Well, it turns out that with semiconductors, it's very much the same. Semiconductors are made up of materials that have a certain type of crystalline structure, and that crystalline structure gives the material some very unique electronic properties. Okay. So modules 1 and modules 2 are going to be about that. Crystal structures and how those crystal structures relate to the electronic structure or the electronic properties of atoms. That's modules 1 and 2. In module 3, we'll talk about energy bands and carriers. So this is where we start talking about the fundamentals of semiconductor devices. So we talk about what is a carrier. So there's two types of carriers. There are electrons and holes. How do these carriers move about the semiconductor? So what is electricity? Electricity is moving charge, right? Electricity is simply moving charge. So when we're talking about moving charge, we have to think about what type of charges we have. There's two types of carriers. One has a negative charge, that's called the electron, and there's something that has a positive charge, that's a hole. Both of these charges, these types of carriers, can move through a semiconductor material, and when it moves, it creates electricity. Okay? So we'll talk about those two types of carriers. We'll talk about the ways that those carriers can move. There's drift and diffusion. Okay? Drift is the movement of carriers due to an electric field. Diffusion is the movement of carriers due to a concentration gradient. So meaning there's a high concentration of carriers here, low concentration of carriers here. The carriers diffuse from one place to another. In both cases, moving charge can create current. We'll also talk about generation and recombination. So that's how carriers are created and how carriers are destroyed. Okay. All these topics basically tell us about the physics of semiconductor materials, how electricity moves through them. We have to understand that as sort of a stepping stone for the second half of the course. The second half of the course is where we talk about PN junctions and field effect transistors. Let me just back up for a minute and finish up. The module 4 is going to be on it's called excess carriers. Okay, but it's basically a continuation of module 3 where we learn about the 4 different carrier processes: diffusion, drift, recombination, and generation. And we talk about how semiconductors respond to light. If you shine a light on a semiconductor, what happens? It generates carriers. What do those carriers do after they're generated? One of the applications of, in module 4, we're going to understand some of the basis of how solar cells work and how semiconductors can serve as light detectors. Okay, so that's one of the big uses of semiconductors right now as detectors. So light detectors are in your cameras, right? When you take a digital camera, you take pictures. There's semiconductors that detect the amount of light. The light detectors are also used in things like I mentioned, solar cells. Okay, when light hits the semiconductor, it generates carriers, and those carriers can actually be harnessed, and it can generate electricity. Okay, so photovoltaics are basically semiconductor devices. So we'll talk about the physics of the interactions of light with semiconductors in the excess carriers module as well. The second half of the course is going to be on diodes. So module 5 is on PN junctions. So we'll start that sometime at the beginning of March, or at the end of, maybe actually a little bit earlier than that, towards the end of February. And then we'll end off the semester by talking about field effect transistors. field effect transistors, or MOSFETs, are the most common type of transistor that's used in microprocessors and in amplifiers. So that's probably one of the most important types of devices. And that will be it. We'll have the university study day will be the end of April, and on April 30th we will have our final exam. That will be in class. So let me talk about the exam schedules. So I would like to have, I'm planning on having the first exam on Tuesday, February 10th. Let's see how that goes. I would like to make sure we cover enough material by then. If not, we can always push the exam back a little bit. But I'm targeting the first exam to be February 10th. The second exam will be right before spring break. I'd like to have it before spring break because no one likes to spend spring break studying and then have an exam right afterwards. So let's try to have this exam the last day of class right before spring break, so you can go and have fun after that. Right after spring break, the plan is to do the clean room labs then. So I mentioned that part of the class module, I changed the class a little bit a few years ago so that we have this fabrication component in there, the manufacturing component. How do we actually make semiconductors? So in the Semiconductor Fabrication Lab, you will go into our clean room facility up on the 3rd floor. As a portion of that lab, there will also be an online lecture recording that you'll watch where you learn about the different tools used to manufacture semiconductors. How do you make a diode, the different steps involved in making a diode, the different tools used to make a diode, and the different tools used to analyze and characterize the diode. Okay. And other semiconductor devices as well. So there are 2 class sessions allocated for the clean room lab. We may need more considering the size of this class. We may actually need to have 3 or 4 sessions. So let's see how that goes. That's going to be a sign-up thing as well. Yeah, last semester there was like 30-some students in the class, so we had half the class go one day, half the class go the other day. This year we may need to have actually 3 class sessions. So let's see how that goes. I'm sorry? Well, the sign-up would be half the class be in clean room, where's the other half? Oh, yes, good question. In the past, what we did, since it was only 2 sessions, the people who weren't in the clean room that day just got the day off. Because there's also, in addition to the lab, there's also an online lecture that you need to watch that's about an hour. So, I mean, it basically came out to about the same thing. So this semester, stay tuned, because after spring break, we'll figure out whether we need maybe 3 class sessions. And if we have 3 class sessions, we might actually have alternate between the lecture and going into the clean room. So I'll figure that out towards the end of the semester. So that clean room lab is kind of fun. Let me see if I can find. Yeah, see, I do have some pictures here. Students always like to take pictures in there, so these are pictures from one of the years. And this is a picture of them looking at, I don't know if you can see this very well, and this, but this is a semiconductor wafer. They're about yay big. This is a piece of silicon here. When we make semiconductor devices, we start off with a piece of silicon about that big, and there's about 26 steps that happens to make a microprocessor. By the time that wafer is done with those 26 steps, it's probably worth several $100,000 to over $1 million, because that wafer actually contains hundreds of microprocessors. Each microprocessor is like about this big. We'll talk a little bit about that later. So what we do in this lab, we basically make just a few semiconductor diodes, so you get the idea of how things are fabricated and made. And so it's kind of fun. These are all just some pictures of the die that we use. It has like 8 different diodes on it. And those little pins that you see on top, That's called part of a semiconductor probe station. So those pins are basically electrical leads that are touching down on different parts of the diode, and you can use that to test the IV characteristic, the current voltage characteristics of the diode. These are also some other instruments in the lab that you learned a little bit about. So in the past, students have said, we wish this lab was longer. Unfortunately, we don't have time to do more than one or two class sessions. But I think it is very important, just having this is very important in understanding how semiconductors work, because the manufacturing technology is just as important as the semiconductors themselves. So in terms of attendance, I do require attendance in this class, and I'll jump back to the syllabus with that in a second. I require attendance during the exams, obviously, and I would like you to check your schedules now and make sure that you can attend class during these dates: February 10th for exam 1 and March 12th for exam 2. I generally don't do makeup exams, so I would like you to clear your calendars, and if you do have a conflict on any one of those dates, let me know in the next week, and we might be able to move the shift at least exam 1 to a date where the class can attend. Okay. Basically, if you have a conflict on one of those dates, please do let me know in the next week. Just come and talk to me after class, and we can sort of work it out. If I don't hear from anyone, I'll just assume that these dates are fine, and we'll just go with those. Also, with the cleanroom lab, you must attend one cleanroom lab session, and so there will be a sign-in sheet there, and there will be part of the. You'll be asked to turn in a lab assignment, and so that will be a requirement. So also, please make sure that these 2 or 3 sessions after spring break that you're able to attend one of them for sure. The rest of the class sessions with regards to attendance. So my attendance policy is that I do require attendance. If you have an absence for personal or medical reasons, you can have up to 3. And just let me know in advance if you plan to miss a class. 5% of the class, 5% of the class grade is for the in-class presentation. 5% of the class grade is reserved for attendance and participation. So it's both. Students who attend all the classes and participating often, like almost every day, will receive a 5. Students who attend most classes and maybe participate a little bit less frequently will receive a 4, and then it kind of goes down from there. Like if 3 and 2 is if you have lower attendance or lower participation, and 1 and 0 is if you have very low attendance or very low participation. So those 5%, it actually does make a difference in your grade. I've found that when I was just grading last semester, 5% can make the difference between a B+ and an A- or C+ or B-. So keep that in mind. The reason I have this type of grading policy is because I like having a class where everybody is participating. I think it's better for you, it's better for the other students for a few reasons. First of all, if you have a question in class, something that you don't understand, it's other people in the class also probably have a similar question, and it's probably because I'm explaining something either too rapidly or I'm making an assumption about something that you understand that you don't. So please do stop me if there's something that you don't understand about the class. I'm happy to go back to it and re-explain it and make sure that we understand. So I encourage you to participate in class, ask a lot of questions. I will also ask questions to the students. I do this kind of thing where I just go and, I may pick people or I ask for volunteers to just quizzing you on different concepts that we've learned in the class, just to clarify, just to review. And so those are your opportunities to, answer those questions, participate. And this gives me an understanding of what the class is understanding and what what the class does not understand. So please do take advantage of that. About the grading policy, we only have a few minutes left here, and I just want to finish up the syllabus real quick. 20% will be on quizzes. The quizzes will be given weekly or bi-weekly and will be based entirely on homework assignments. The homework assignments themselves will not be collected. And I post the homeworks. I post the homeworks online. I also post the homework solutions online. Now, I'd probably spend a half an hour talking about this, but I'm going to condense it down to a few minutes. Please, when you do your homeworks, don't rely on the homework solutions. Do the homeworks yourselves, and only in only if you spent like an hour on it and you're getting frustrated, then you want to look at the solutions. That's fine. The reason for this is because I've found that students who just look at the solutions right away, they always end up doing poorly on the exams, and they always tell me later, well, it seemed, when I did the homeworks, they seemed really easy. They seemed fine. And I always ask them, did you look at the solutions at the beginning? Did you just follow the solutions to do the homework assignment? And they always say yes. You don't know what you don't know, if you have the solutions in front of you. So when you attempt a problem and you struggle with it and you don't know how to do it, and you try different things, you look up things in the book and you try something, it doesn't work. You look up something else, it doesn't work. And finally you get to it. That struggling is where all the learning is happening. I can't say this enough. I could talk, like I said, I could talk about a half an hour about it. It really is very important that you spend that time struggling with the homework problem so that you can learn. So my advice to you is I will post the solutions to the homework, but please do not use them unless absolutely necessary. 2 midterms, just a few minutes, please. 2 midterms, each 20%. 30% of the grade will be the final exam, and then 5% of your grade will be your class presentation that you do in class. Okay. The class presentation is graded on the following rubrics. I will touch on this a little bit more in the next class period, but just read through this. The presentation should have a clear relation to solid-state electronics. It must present something, a new or recent technology. There has to be sufficient references, at least 3 to 5, and they should be reliable references, not just some random website, but just a journal article or a magazine like IEEE Spectrum. And the presenter should demonstrate a thorough understanding of the presented material and the technical content, quality and clarity of the presentation, and the enthusiasm of the speaker, and the timing. The timing, we're actually going to probably have a 5 or 6 minute limit this term, just because there's so many students here, and we want to make sure that we have enough time to cover class material. The rest of the stuff you can read on your own. The grading scale is on here. The reason it says subject to change is that at the end of the semester, sometimes I bump up grades based on a curve. If you're borderline between one grade or the other, I'll sometimes bump up a grade. Okay. Cheating policy, self-explanatory, and then the stuff on Blackboard and feedback is all also pretty self-explanatory. So why don't we end there? If you have any questions or concerns about the class, come talk to me after class. I'll see you guys, see you all next week. Where's the sign-up sheet also? Is the sign-up sheet around here? Okay. So if you could please bring that up. Thanks, everyone. I will see you on Thursday. Yes. Oh, yeah, and also the sheets that you wrote out yourselves, please also just leave those up here if you don't mind. It depends on they'll be on different days depending on what material we've covered.
And are you going to tell us which day we will have, let's say, 2 days?
Yeah, I'll announce the quizzes in advance.
Because with work it's kind of hard
Sure, sure, sure. Yeah, I'll let you know when the quizzes will be. Yeah. Okay, no problem. Yeah.
The presentation, we have to read it on PowerPoint or it's
Yes, PowerPoint.
PowerPoint?
Yes.
And the syllabus, you will be posting it on the Blackboard?
Yes. I will post the
You
syllabus.
don't mind how many slides we have, right? For the
Um,
PowerPoint. As long as we take for 7 minutes or 6, 7 minutes, it will
yeah.
be okay.
Yeah, typically 5 slides is enough.
Okay.
Yeah, not more than that.
Thank
Mhm. All right, thank you.
Okay.
Thank you.
I want to talk to you about research opportunity I was looking for in the summer.
Mhm.
I'm interested in something with computer programming or software development,
Mhm.
but I did work with Mark Chan's project and I used console, so I did that software, things like that. So
Mhm.
if you have any information or a person I can contact, if you had the opportunity, maybe
Well, what type of software development are you interested in doing?
anything. I'm just really want to learn something new that I never done
Mhm.
before.
You're interested in software. You interested in Android?
Yes.
Okay. I have a student who's working on an Android project right now. She's working on a smartphone app that can talk to a wearable sensor for health monitoring.
Okay.
If you're interested in that, I can put you in touch with her, but it would be in the summer, right? Yeah, so just contact me later in the semester then. The thing is, I may be gone for a part of the summer because I'm going on sabbatical next year. So that's something to keep in mind here. But I might be able to put you in touch with her and you can work with her.
Thank you.
Okay, yeah, no problem. Yes.
I might have some family emergencies in the following 2 months.
Uh-huh.
So I already do. Because my mother-in-law,
Oh, okay.
she has cancer and
Oh, I
it's
see, I
stage
see.
4. So
Oh, I
so
see,
it's
I
not,
see. I'm
everything's
sorry.
not predictable.
Yes, yes.
Right? So the tendency or maybe exam time, there may be a chance I may miss it. So
Okay, keep me posted. You just keep me informed as soon as you know. Okay. Yeah, let me know beforehand, like if you're planning on being out of the country, out of town. Okay. Right.
Like a student,
Yeah.
question like I have a required class in Korea.
Mhm.
The name is electronic materials, and
Okay.
we cover with this book. So is it as you go within a class? I think it's the same. They have Korean like it has Fermi in something like Hall effect.
Yes, yes, yes. That's the same class that this is about.
I think this class also cover with the Semiconductor.
Yes, definitely, definitely. Just a sec here. Yeah, it's the same class basically. So, have you taken this class already?
No, it's my first
Okay.
time too.
Yeah, then you could probably get equivalency for that class back in your at your university. So is that what you were asking?
Yeah, and
Yeah.
like I'm a student and I have a little bit of problem, speaking English or something like that. So I'm trying to do my best.
Yes.
But, like,
That's fine. I think you'll do fine.
because
Yeah.
I'm just exchange student, so I just arrived like August last year.
Mhm.
I'm learning English for now.
Okay. Yeah, I think you'll be okay. Other students have there's been other Korean exchange students as well, and they've all done fine in the class. Yeah. Thanks. We'll on our way out.
maybe I'll talk about next class, but your syllabus for the final exam,
Yes.
like 1:30 to 5?
No, it'll be at the same. I think it'll be at the same exam time, same time as the class here. Yes, yes, yes.